In number 30, we're going to see where algebra is once again brought into the mix with these geometric shapes and all the different angle relationships that we've been talking about. And you see the diagram here that's got a couple of parallel lines that are running horizontally through it. And we're trying to figure out what x is and what y is. And we have to recognize that these lines could be extended, and sometimes as you're doing this it might be helpful for you to visualize a little bit. If you extend those lines, it might be a little bit more clear. For example, if I cover up that part and just look over here, I see two perpendicular lines with a line that's running through it that's my transversal, and now I can look at 60 and 3x and say, okay, what kind of angles are those? Well, those are corresponding angles. What do I know about corresponding angles? They're congruent. So then I can come over here and say, well, that's my algebraic equation. 3x is going to be equal to 60. If I divide both sides by 3, x is going to have to be equal to 20. Okay, but I can only set up that equation if I first recognize that's my transversal, two parallel lines, corresponding angles have to be set equal. Okay, on the other side, I've got 5y minus 5. I've got 135 degrees. I've got my 60 degrees up here. And if I'm trying to solve for this y, one thing that you might be tempted to do is to look at 60 compared to this 5y minus 5 and say, hey, aren't those alternate interior angles? And some people do that where they extend this and say, okay, here's one line, here's another line, and then there's my transversal cutting through. These are alternate interior angles. The problem with that kind of thinking is that these two lines, this one and this one, are not parallel. So although this is a transversal that cuts through those two lines, because this one and this one are not parallel, we can't say that these alternate interior angles are going to be congruent. So instead, to solve for this 5y minus 5, I can look at it compared to this 135 down here. And once again, you might want to extend this out a little bit. And so we're just looking in this area here. And here's my parallel line that's parallel with this one. And now this is my transversal. When that's the case, I recognize that these two angles are consecutive interior angles. What we know about consecutive interior angles is that they always add up to 180 degrees. So that's going to be the equation that we use. Consecutive interior angles have to add up to 180. So that 135 and the 5y minus 5 add up to 180. I'm getting that from this. Okay, then you can combine like terms. So 140 plus your 5y is going to give you the 180. Let's get rid of the 140 from both sides. That would leave me with 5y, that would leave me with 40. Divide by 5, and y is going to be equal to 8.